All right, all right. It's night talk. It's night talk. We got another episode of Night Talk. There we go. All right. Welcome, everybody. Come on in, grab a seat. We've got a wild one for you tonight. For those of you new to Night Talk, this is where we campfire under the stars and chat about everything here on Instagram. All right, so I'm your host, Gabriel Biederman from National Parks at Night. Thank you for joining us. Come on in, sit down. Yes, yes, yes. And comment below where you are tuning in from. And while you do that, I do have a couple quick announcements. We've got a PSA here. And first one is we have some free night photography videos posting up this week. If you want to get a taste of previous Night Photo Summit classes, every Tuesday and Thursday leading up to Night Photo Summit, we are showing classes from our previous years. Remember, this is our 5th year, folks, of doing the Night Photo Summit. And this Tuesday, that's tomorrow, January 14th, we'll be streaming Unlocking the Full Potential of Astro-Modified Cameras with Dan Zafra from Capture the Atlas. How do you get this free podcast? It's quite easy. You just go to the Night Photo Summit website, which is 2025.nightphotosummit.com. You can check our link in the bio. That's easily where it is. And at midnight, as soon as it turns 12 a.m. EST on Tuesday, so that's for us on the East Coast, that's just in 4 more hours. It'll be right there on the homepage. You just scroll down a little bit. Also, heads up, Dan will also be joining us on a Night Talk on this Sunday too. So we're getting some Dan Zafra love going on. All right. So I see quite a few people here in the chat. Again, feel free to drop in. I see Jody. I see Donna, Kimberly. I see Justin, Debbie Strong, Charming Pics. I don't know your first name, but that's a nice one. I got Auburn, New Hampshire. Toronto is in the house. Somewhere in Sweden, upstate New York. We got quite a few people. So really, really excited to have you all here. And just remember, folks, that, again, please drop any questions that you might have for Vincent in the chat. I have a bunch of stuff prepared, but we also want to hear from you. So, all right. Are you guys ready? We're going to do this intro. First off, who here has always wanted to see the auroras? I guess put in if you've seen them, but if it's still on your bucket list in the chat. And what about learning more about the auroras, right? For many of us, this is something we've only maybe experienced in the last 1 to 4 years, and just how this phenomenon occurs. Well, we've got a guy, the Aurora guy, in fact, Vincent Ledvina. Vincent is the leading force in aurora chasing community. He lives in the higher latitudes in Alaska and is a physics PhD student at the University of Alaska Fairbanks. Aside from his current research, which focuses on aurora beads and the plasma processes responsible for causing auroral substorms, he is passionate about sharing his love for the northern lights with others. So, without further ado, let's give a warm welcome to Vincent Ledvina.
Hey,
Vincent.
I'm doing well. Thanks for having me. Really happy to be here and excited to talk about the aurora.
Right? Like the aurora, like the one, the best one we're ever going to experience, right?
Hopefully. Fingers crossed.
Awesome. Well, really, thank you for taking the time. Speaking of time, what time is it in Fairbanks right now?
4:05 p.m. So a little bit,
PM. So,
yeah, 4 hours behind Eastern. So sun has already set, though.
I love it.
It's set a while ago.
Well, at least you got some sun, right? You're just coming off of total darkness, right?
Right. Yeah, almost. So in Fairbanks, we don't quite get 24 hours of darkness, but I mean, the sun only comes a few degrees above the horizon on the solstice in the winter. So I think we only actually have roughly 3 hours of daylight in the winter, but it sure feels like we don't have any, because if you're not outside with a clear view of the horizon, you'll just never see the sun. So It's important to get outside, as much as you can, and and at least enjoy the small amount of daylight we have, because that's how you have to stay sane up here.
So, how many night photographers tuning in would like to live in Alaska during the winter, spend 2 or 3? Because how many hours you get? You get like 15, 20 hours of darkness.
Yeah, you get 15, 16 hours of like actually like shootable darkness where you can get stars in your photos, which is pretty cool.
Awesome. Awesome. All right. We have the comments are rolling in. Ed Finn has seen the auroras, but he's eager to see them again. I don't know. OG4R1 something is he has seen them many times throughout 2023 and 2024 in Southern Ontario. Yep. That's a good spot.
Nice. Yep.
We got Chris from Southwest Michigan. JT Malak is I'm in Alaska, so I see them often. It's like whatever, picking up a phone, I guess, and just tuning into Alaska time. Let's see what else. Terraston, seen them in May and October. Justin, I really want to experience the southern lights in higher latitudes of Alaska or Iceland. He's a Michigan guy. He's a Michigan guy, which Michigan is like a sneaky state. Michigan gets some the mitten prevails.
Yeah, Michigan. Honestly, all the mid-latitude states in the U.S. and by mid-latitude, like the U.S.-Canada border states, they get auroras probably, and this is during solar maximum when we have more space weather going on. I'd say probably once a week. I mean, you have photographable auroras, so people have this idea that you need to travel to Alaska or Iceland or Norway. I would say personally that the auroras up at high latitudes are just a different breed than what you can experience out at mid latitudes. So it still is worth coming up here, but people, maybe don't realize that they can photograph the aurora. They can even see the aurora from their own backyards, which I think is really awesome.
Yes, which I'm sorry, Justin, I stand corrected. He just moved to Maine, the other M state.
Even better, even further north.
That's pretty good. Ann Fulcher, hey Ann, she's heading back to Lofoten. That's going to be awesome. Nice. Wishing you all the best there.
Alice.
And then ZV Icos, got to see them from Texas and Colorado in October, and just got accepted to UAF for the fall, and hope to see them a bunch next year. Right on.
Sweet.
Awesome. So also, Vince, before we start off, tonight is the full wolf moon, right? So let me ask you this. This is a big question that we get from a lot of people, is that you can't see the auroras during a full moon.
I think you already know what my answer is.
I think I know. Well, let's get the science of it.
So, with everything in the aurora, there's like the short, if you're going to throw it into an Instagram reel answer, you just need like one line. And the answer is yes, of course you can see the aurora during a full moon, but there's always caveats, there's always nuance. And, with a full moon, while you can see the aurora just, sometimes even better than during a new moon, at mid latitudes where the aurora is usually near the horizon, the full moon can definitely diminish the display, because when you're at mid latitudes, you're looking towards the horizon usually at the aurora, and you're also looking through all that haze, all that mist and dust. And I used to live in North Dakota, so even during the winter we'd have stuff from the fields getting kicked up by winds, and that created this sort of brown layer of haze and dust on the horizon. So all the auroras that I would photograph, if they were really minor and sort of really low level, they would almost look yellow because of it's actually the same effect that produces red sunsets, right? This sort of dust. So I get a lot of yellow auroras down there, but actually the full moon can enhance colors that you see with your eyes, because and I can get into this later in more detail, but our eyes don't see the aurora the same as our cameras do. Obviously, we have cells like rods and cones, and cameras have pixels on a sensor. So these rods and cones are responsible for how we see. The rods are responsible for the sort of low light vision that we have at night, but it only gives us black and white, and we don't get a lot of detail with that. Our cones, on the other hand, When we're out in the daytime in the sun, our cones are active. They're letting us see colors and details, but at night they kind of turn off. They sort of shut off. They become deactivated. They need a little bit of light to turn on. So actually the full moon provides enough light to activate your cones. So usually with a really powerful aurora, you can see the colors during a new moon because the aurora is bright enough to activate your cones and turn on your color vision. But if you have a really weak aurora under the full moon, your cones are still activated, even though the aurora is not necessarily bright enough during a new moon to see the colors. A full moon, you can see the green. So actually, I really prefer full moon auroras for the viewing experience alone because you can see the greens. I can, of course, everyone's eyesight's different too, right? As as we age, things change, but I can see the greens all the time up here during a full moon. So, yeah.
I love it. I love that answer. We get so much slack if we do a workshop or we go with some moonlight, there. And one of my first shots of the auroras ever was actually these auroras are wrapping around a setting moon. And it's one of my favorite shots. It's great.
That's cool.
And also let's remember, folks, that moonlight gives us more detail on the foreground as well. Right. So that's a super bonus. We can see better. That's an awesome fun fact that I don't think many of us knew. But again, the bonus of that you're getting better sort of foregrounds or better lit foregrounds.
Yep.
I see some questions coming in, but I want to get to the basics first because you're already dropping science left and right. So let's go back. Let's start from the beginning.
Yep.
When did you first see an aurora?
Yep.
And how soon did that chase start?
Yeah, well, I saw my first aurora when I was 4 years old. So back in 2003, there was this big geomagnetic storm called the Halloween storms on October 31st, 2003. I'm from Minnesota. I'm from the Twin Cities. I grew up in the suburbs. You'll know where that is. It's it's kind of like a Bortle 6, Bortle 5. So not great for night photography, but the aurora is pretty bright. So I actually saw the aurora in 2003 from my front yard, walking in with all my candy, and it was really beautiful. And I actually, that's one of the few childhood memories I still have, is of seeing the Northern Lights dancing across the sky over the Twin Cities. And obviously I didn't pick up a physics textbook when I was 4 years old. I didn't go out the next day and start grad school, but I think that experience really embedded this passion for the night sky, for the outdoors, and for just really, kind of having this relationship with nature through photography. I think that for me, the first time I picked up a camera was in like first grade. On these family trips, I would take cameras and just record what I was seeing. It was a way for me to not only remember what I saw, but also sort of take a moment and appreciate the nature around me. Use my camera to focus in on something that maybe people kind of don't notice, like, a really kind of macro scene on a flower, or, trying to align buildings, a certain way to get a cool composition. So, photography for me was always, central to my experience outside. And then I combined that with my passion for the night sky and science when I was in high school, learned about the Northern Lights and sort of remembered, hey, I saw this aurora back when I was 4 years old. And then I actually connected the dots because I was like, did I even see that? And then, sure enough, there was this huge storm on Halloween night. And I was like, yeah, of course that was the aurora. At the time, actually, we didn't even know what it was. So when I was 15, 16 years old, I started learning about space weather data, about the aurora, the science. I was in high school. I chose to go to my undergrad at the University of North Dakota. That's where I got this aurora guy name. People started calling me that. So just on campus, I started posting my photography when I was around like a sophomore in undergrad, and all of a sudden people came up to me on campus and said, hey, are you that aurora guy? And I said, I don't know, I guess maybe I am. And my friend said, yeah, Vince, you're the aurora guy, just embrace it, this is what you do, like, you're obsessed with this stuff. And so I ran with it, and I had a lot of really fun experiences in undergrad that shaped what I really wanted to be. I mean, I was always into space weather, always focused on that. Wasn't sure if I wanted to pursue it as a career necessarily, but I chose to go to school for grad school at the University of Alaska Fairbanks. Now I live in North Pole, Alaska. It's just a suburb of Fairbanks, but it sounds cooler to say North Pole. And I'm studying up here. I've been here for 2 years. And yeah, I basically chase the aurora every single night I can. And I'm constantly tuned into space weather, on the pulse. And my mission is just to help people see it, because it really did change my life. Not only when I was 4 years old, but when I kind of reappreciated everything. I saw this amazing aurora, which we'll actually see a photo of later on in this segment. But from 2022, I was up in Alaska, saw my first high latitude, what's called an auroral substorm. And that really just like changed my life. So I want everybody to have that same experience, basically.
Awesome. It's very special. And wow, the Aurora guy. That's it. That's the, I love it. I love it. So I already talked about that Halloween Aurora.
Yep.
And we've been obviously a little busy and some pretty fun ones these last few years. What has been your favorite Northern Lights experience so far?
Ooh, I would honestly say, and I actually have a picture. So again, kind of teeing this up, but I have a picture later that we'll probably see. But it was March 5th, 2022. I remember the date, and it was in Fort Yukon, Alaska. It was my first high latitude auroral substorm, and it was just amazing. And it still is to this day, like one of the best auroras I've ever seen. And yeah, I mean, it's one thing seeing the aurora at mid latitudes, and I'm not necessarily, saying that it doesn't look as good, but it's just a different experience when you're right underneath it. And that's what you can get when you're, right under the auroral oval in Alaska or Norway or Iceland, is this sort of 360-degree surround experience with, these really dynamic auroral forms everywhere around you, overhead spirals, just, moving just like, inconceivably quickly. Like, I think that's the thing that really wowed me the first time I saw this substorm, was that I didn't realize the aurora could A, get as bright as it did, and B, move as quick as it did. I think that just really almost freaked me out. I mean,
and this you this to the eye as well as to the camera. Did you have a camera?
Oh, yeah.
You had a camera because I'm going to see the picture. But you were
I had
back and watch it too.
Yeah. I mean, like still to this day. So I mean, I was doing a lot of time lapse back then. I still do time lapse, but I really prefer just kind of run and gun with my Sony A7S and a 35, just kind of pointing it at the sky whenever there's a big aurora, because then I can kind of like have the camera over here and actually be looking at it with my own eyes. I still prefer just basking in the moment. And I mean, I had tons of cameras going, but they were all on time lapses, so I didn't have to touch a single thing.
That's
which is
awesome.
The beauty of time lapse.
Let it go, let it do its thing.
The moment for what it is. So it was amazing.
Awesome. And I see some science questions coming in. I'm going to get to them, folks. We want to set the table a little bit more here. So as we kind of hinted at, and as most of us know, 2024 was an insanely peak year for auroras.
Yeah.
And things look very bright and colorful for 2025. We've all heard that we're in this solar maximum. Besides the marketing that goes behind this, what does it really mean for people who are ready to chase those beautiful lights?
Yeah, I mean, part of it is marketing, but the marketing actually, for once, does have some scientific backing to it. So if you see people say, hey, 2025 may have the strongest auroras we've seen in 20 years. I mean, I've been using that now for, a few days. There's actually some truth behind it. And the reason is that, just to kind of back things up, right? People were saying this last year too, and they would have been right last year, because we're now sort of at the very crest of what's called the solar activity cycle, or the solar cycle. It's an 11-year cycle, sort of follows like a bell curve, if you can imagine that. And right now we're basically at the top. We don't know if we're at the very tippity top, if we're approaching the top, if we've already crested the top, because to really say that you've been at solar maximum, now you're descending, you have to have seen the top. So we haven't necessarily seen the top yet. It'll probably take us 6 to 12 months to actually say, hey, we've already reached solar maximum, now the activity is declining. But what this activity is that the sun, even though it looks just like this unassuming white ball of light in the sky, is actually producing space weather all the time, every single day. And not only is there this constant solar wind that flows out of the sun, kind of like a hot cup of coffee, how you have steam rising off the top. If you imagine the sort of coffee inside this cup as the sun, it's constantly radiating this solar wind outward. So it bathes all in everything, all the planets, asteroids, moons, whatever, in the solar system, with this solar wind, which is charged particles traveling at millions of miles an hour. And the solar wind is space weather as well, but there's always solar wind happening. What was really important is that Sometimes you get big gusts of solar wind, which are called coronal hole high-speed streams or just high-speed streams. And these, can last multiple days. So now all of a sudden you have the solar wind blowing really fast. And then sometimes you get these big explosions of plasma, like sun sneezes. Those are called coronal mass ejections. So they're kind of like gusts of wind or like fast streams of wind. And then there's these big sort of explosions or sun sneezes, coronal mass ejections. And that's what gives us the space weather. That's really what gives us like the day-to-day variability. There's already some day-to-day variability in the solar wind. But these big storms, these solar storms, cause more energy from the solar wind being inputted into Earth's magnetic shield, sort of charging that up, and that energy kind of exhausts into the auroral ovals down into the aurora. So you're always going to get auroral ovals because there's always some energy in the solar wind flowing into the whole system. And that's why we see aurora up in Fairbanks, for example, every single night, even if the space weather activity is quiet. But when we have these big solar storms, now all of a sudden these auroral ovals have more energy being dumped in. They're allowed to expand to lower latitudes, and the auroras get brighter, and they're seen at lower latitudes. And you can get auroras down in Texas, for example, we actually had many days,
insane.
Many nights where we had auroras in Texas. But this solar maximum basically means more of these big gusts of solar wind, fast streams, coronal mass ejections, which will hopefully give us more chances of seeing northern lights. And what's really special actually about, and this is sort of, people might not know about this, but and the reason I'm saying this is because I get a lot of comments that say, okay, well, we're already at the peak. Now what? Am I not going to be able to see it for the next 5 years? Because the next solar maximum, they just look at these forecasts. They say, okay, well, cycle 26, we're in cycle 25 right now. Cycle 26 is supposed to peak in, 2032 or whatever, right? Or I don't know. But, in like 10 years. And I say, no, it's fine. Because first of all, there's always auroras at high latitudes. Don't have to worry about that. You're safe to plan your trip to Alaska. Doesn't matter. But even if you're down in New York or Michigan or Minnesota, Montana, and you want to see these auroras come down to your latitudes, actually on the descending phases of solar cycles. So we're talking, potentially this year, we don't know if we've, crested yet, but, assuming we're cresting this year, maybe we crested last year. This year, 2026, 2027, statistically speaking, there's actually a little bit of a bump in auroral activity before things start to quiet down. So actually, we're fine. People should not worry. The descending phases of solar cycles are slightly more active for auroras. So things actually should just keep ramping up this year and even next year until maybe we start seeing things decline in like 2028. So we have a lot of time. We have a lot of time for a lot of really awesome space weather.
Exactly. And I tell you, I think we've been going out to the higher latitudes, for the last 10 years. So we probably started a lot of our adventures and stuff like that during the bottom part of the solar minimal, right? But we've seen great shows. It doesn't mean that that's it, as you said, right? The sun is active all the time.
All the time.
You never know. Every year we're going to get some, right?
Yep.
It's just the maximum is definitely more and more active. And so I think that answers, I think Ed had asked, how long will the solar maximum last? Again, we're on the Big Dipper, really I feel still at that top there. We're still clanking. I feel, at least. So things are feeling really good. And I think we got a nice comment. Anna Luis Santos is what a wonderful story. Going back to your personal story. I live in Fairbanks. And the lights are my absolute favorite thing up here. So we were getting some technical questions, and I think you touched upon this quite a bit. But let's, knowing what you kind of just commented, chat just more of that basics part on how they're created, and how they get to Earth. And then when you've kind of get to that point, I'm going to sprinkle in some of the questions we're getting from the crowd here. So
sure. Yeah. So let me just sort of kind of rewrap what I just said. It always helps to hear it again. Things change, right? So we have the sun, and the sun, goes through these solar cycles. That's part of the space weather. Basically, weather means that things change, right? And the point that I'm trying to drive home is that what you're seeing in the sky, the auroras, are sort of the direct sort of visual manifestation of what we call space weather. And like we have weather on the ground, we have rain, we have wind, we have clouds, storms. we have the same things in space. They're just invisible to us. Most of the time, we can look at the sun and we can see these big explosions coming off. We can see the, energy sort of bubbling away, but all that's charged particles. And then that sort of gets really wispy and faint. And then it sort of disappears from our view until it hits Earth's magnetic shield. So let me just back up there. Earth has a molten solid core, and that sloshing motion creates, just like a bar magnet, this dipolar magnetic field that flows not only inside our planet and on the surface as well. That's why we have compasses that work. But that magnetic field extends out into space and sort of protects us in this bubble, which I sometimes say is the magnetic shield, but it's also referred to as the magnetosphere, because on in a perfect world without solar wind, it would just be this, perfect bubble, like you would just blow a bubble. But we have this solar wind that sort of, hits our planet, creates this pressure on the day side, the side facing the sun. It compresses that. And then the side that's on the night side, the nighttime side, the side not facing the sun, becomes dragged out in what's called a magnetotail. So basically imagine like a stream of water, and you place a rock in it, you have this sort of wake that follows, or like a boat, sort of moving through water. You have this wake that forms. So that's actually what our magnetic shield looks like. And the solar wind that's constantly flowing out from the sun carries with it energy in the form of charged particles. And those charged particles also have magnetic fields. So, and this is key actually, is when you have a negative pointing magnetic field in the solar wind, and Earth's magnetic field is always positive. It's flowing. If you're sort of imagining like looking down at the Earth, it's flowing out of the South Pole and then back into the North Pole. So it's facing up. So now you have this solar wind magnetic field flowing down. You have Earth's magnetic field flowing up. You bring them together, and just like you bring two opposite polarity bar magnets together, they sort of click. The energy can flow from the solar wind, and then the weak points of Earth's magnetic shield are over the poles, which is why we see aurora over the poles. And this energy flows down in the form of charged particles. So, I say energy, but really we're talking about particles that have a certain, velocity or like momentum. And there's also magnetic fields with those particles. So it's a little bit more nuanced, but the actual way that the light is produced is that these particles are streaming down along Earth's magnetic field lines. Those magnetic field lines actually, intersect with our atmosphere. These particles are like surfers riding along waves, and all of a sudden the waves run into the shore. So they skid into the atmosphere, and then like a game of Plinko, they start bouncing around the upper atmosphere, and they start hitting different things on the way down. So the first thing that they encounter are these oxygen atoms, and those glow red. So that's why the tops of the aurora look very red. And then if they have, sometimes those particles, if they're really low energy, they'll just stop there because they don't have anything more to make it down. But if they have more energy, they have more juice, they'll make it down to lower altitudes. Then there's nitrogen and oxygen that together produce green. So now you have red and then you have green. And if you have even more energetic particles, you'll get red, green, and then there's a little layer of diatomic right below the green, and we get this little pink fringe or purple fringe that you really only see during the most active aurora. So when you see the auroras dancing, you might be able to remember, oh yeah, I saw this like weird kind of purple pink fringe, sort of like almost like a ribbon sort of dancing along the bottom of this auroral curtain. Well, that's because those particles had a lot of energy. They made it all the way down to that N2 layer. And then none of the auroral particles actually make it to the ground. None of these particles coming in really make it further down than like 80 kilometers or something. But that's how the aurora is made. So from the sun, to the surface, to the atmosphere of Earth, there's all these interactions that take place, all this transfer of energy. But really the main point is that everything's driven by the sun and solar activity. But Earth's magnetic field has, a say in this. It's not just the particles from the sun directly impacting our atmosphere like a lot of people think. It has to interact with our magnetic shield, and there's sort of this, it's almost like scrambling up an egg, right? The sun's throwing all these eggs at Earth, and then Earth is scrambling them up, and then we're given the scrambled egg, which is the aurora, essentially. So
how long can our shields hold up, Scott? How long can they hold up?
They've been holding up for a while, so I think they're going to hold up for a while longer.
Okay, all right. We got a question from OG4R1, et cetera, sorry, asking, how do coronal holes on the sun work?
Yes. Okay. So coronal holes. For those of you who are not familiar, and maybe this is because there's currently one facing the Earth, and I was doing some work this morning on the plane to sort of dispel all this conspiracy, because when you see a picture of the sun taken in extreme ultraviolet light, you're looking at the magnetic fields of the sun, so not the same wavelengths that we look at here on the ground. We see things in visible light. You're not supposed to look at the sun anyways, but if you go into space, you put a special sunglasses, quote unquote, on a telescope, you can look at the sun in different wavelengths that would otherwise get blocked out by our atmosphere. So one of those wavelengths, or sort of range of wavelengths, is this extreme ultraviolet range, and you can start to see the sun's outer atmosphere called the corona. And at that point, things are bound by magnetic fields. It's not gravity that's holding this plasma together as much. So really hot areas are closed magnetic field lines. So you can imagine these particles bouncing along, back and forth, both ends of this, field line that's connected on both ends on, somewhere inside the sun's atmosphere, but it's sort of this loop. And that motion, this bouncing motion, causes the particles to heat up. In the images, they look bright. So you see these bright areas in EUV images, extreme ultraviolet images, around active regions, which are, the areas above sunspots in the sort of outer solar atmosphere. But if the magnetic field lines are open, so instead of being a closed loop, they're just open out to space, basically right into the solar wind, the particles, they sort of come up from the sun surface and they just stream right away. So they're not being bound by anything. They're not bouncing around. They're not hot. They're cool. In the images, they look dark. So you have all these dark patches on the solar, in the solar atmosphere, and scientists call those coronal holes. So they're not actually holes in the sun. They're just open magnetic field lines where the particles are not, impeded by the magnetic fields. They can flow, freely. It's almost like you have like an HOV lane, right? And you're just able to speed right ahead of all these other cars that are stuck, on the shoulder or in the right-hand lanes. So these solar wind particles come just barreling out from the sun, and normal solar wind is like 300 to 400 kilometers per second, which is still really fast. But these coronal holes, the solar wind's really booking it. I mean, it could be up to 800 kilometers a second. Usually it's around 500 to 700 kilometers a second. But, if you imagine the solar wind's coming out even faster, it has more energy. So, logically then the auroras sort of respond and they can become amped up. We can get some minor geomagnetic storming. And usually those coronal holes, once we see them, so, we're sort of at Earth and we're seeing the sun over here. We're constantly looking at the same side of the sun, the side facing the Earth. So when we see stuff at the very center of the sun from our perspective, that solar wind's coming right at us at that exact moment. So solar wind usually takes around 2 to 3 days to get to us. So when we see that coronal hole, the very center of the sun, we know that solar wind coming out from that coronal hole, as we're seeing it, is going to get here in like 2 to 3 days. So when we see that coronal hole at the very center of the sun, start a timer, 2 to 3 days, you'll get hit by this fast stream of solar wind. And what it usually looks like is, because there's this fast stream of solar wind and there's all this slow stuff in front of it, you get like a snowplow effect as you get the solar wind sort of butting up against this slower solar wind, this fast solar wind coming in, sort of creating this like big mountain of particles. And at Earth, we'll see this big ramp up in density over the course of a day, this sort of dense solar winds coming. And then we know that behind that's this fast solar wind that's going to sweep past. So actually, right in the beginning, when you have this sort of transition from the dense to the fast, is where you get the best chance. So that's crash course in coronal holes. And there's one facing Earth right now. Not sure exactly where it's at, but I think in the next day or two, we should get a coronal hole high-speed stream. Also, these coronal holes can be really big. They can be like half the, sort of width of the sun. They can look huge and ominous. They can be really small. It's sometimes hard to know. I mean, if you see this little kind of snaky coronal hole like we're seeing on the sun right now, I mean, I looked at an image of it this morning. It probably hasn't changed that much. So when I saw it this morning, it was kind of like this snake. It was very long and it, extended across a lot of longitudes, but it was fairly narrow. And, sometimes you don't actually get anything from that coronal hole because, if you're trying, it's like trying to, aim a, it's like you're trying to do one of those trick shots, right?
Yeah.
Like you might not get it if the, if your little
ping pong ball's
target is really small. Right, exactly. So yeah, I mean, we'll see, but yeah.
Love it. Aurora Pong.
Aurora Pong.
As the Aurora guy, you're always alerting the Aurora community of upcoming aurora activity, and you're hinting 2 to 3 days, set your alarm, etc. But then as it gets closer, you get a better idea. Can you share, and we have I know a couple questions already for some of the specifics, so I think you're going to probably cover in this question. Otherwise, folks, I will, and I'm talking to you, Pat and the cat. We'll get to your questions as well. Can you share your process for forecasting auroras?
Yes. Well, I will say that, I'll say two things. My biggest sort of asset that I have is experience. I've been out chasing for hundreds of nights, and I check the data all the time. I think that to be a better aurora forecaster, better aurora chaser, you just have to be watching the data. You learn so much, without actually learning the science. So, you can pretty much forecast the aurora just by looking at a picture of it on an all-sky camera and knowing the time of the day or the time of the night, and you're seeing that aurora. You can pretty much know what's going to happen in the next 5 to 10 minutes. And that's really that sort of time range that I would say is when we can make an accurate forecast, is between 5 and 10 minutes. Otherwise, everything is kind of a guess, right? And those guesses get more and more uncertain as we lengthen that time window. And I will say another thing too is that if you don't want to learn all the science, which is totally fine. I mean, not everybody needs to learn about coronal holes and why they exist, and the solar cycle and all this stuff. I think it's helpful to know. It's really great context. But you can just look at aurora webcams. You can go on Facebook, join Facebook groups, and just wait for people to start posting. Webcams are even better. If there's a little pop-up aurora at 4 a.m., people might be asleep. Maybe you're up, and you can check the you can check the webcam and see, okay, yeah, the aurora's out. Even though space weather is, moderate to mild, sometimes auroras just kind of happen too. Obviously there's always an explanation, but they just seemingly pop out of thin air. And a really good way of knowing when that happens and just monitoring things is to look at these webcams, join these groups. Aurorasource.org is another one of these sites where you can see live auroral activity being plotted out through user submitted reports. But if you want to go beyond that and actually monitor things and sort of anticipate when things might happen, starting from the very sort of broadest, if you just want to glance at something, you can look at the NOAA 3-day KP forecast. I don't like KP, but if you look at the NOAA, 3-day KP forecast, if there's a KP 5 or 6 or 7 forecast in the next 3 days, okay, well then that tells you something is coming. You don't even need to know what it is, but you just know that, okay, there's an enhanced activity period coming up. I should start paying more attention. It's like, you tune into the TV and, all of a sudden you just hear about this high risk, severe, weather chance for Tuesday, right? And today's Monday, or let's say it's Wednesday. You don't necessarily need to know how to follow the radar or like look at every single, balloon sounding and look at these hodograms or any fancy thing. You just know that in 3 days, there's a higher chance of severe weather. It's the same thing with the aurora. NOAA will tell you, okay, yeah, we have a G3 watch, KP7. I mean, I would pay attention to that, right? Like even though I don't like the KP, there's something coming supposedly. So I would say that, right? Just bar none, look at the webcams, look at the 3-day forecast, just to kind of, always be up to tabs with what's going on, sort of your current events, if you will. And beyond that, you can use current events. You can use things like the KP, if you want, even though I totally don't like it. It's too coarse grained for me. But there's also something called the Auroral Electrojet Index, which is nice because it's, again, higher number equals better. There's something called the Ovation Prime Auroral Oval model, which gives you like, it's a model. It's not actually the auroral oval, but it's not ground truth, but it gives you an idea based on all the solar wind coming in. It cooks it in this fancy equation, says, okay, well, the auroral oval should look like this, and it gives you a nice little donut shape. So on and on. I don't know how much you want me to go into it, but if there's other questions, we can go back to it. But there's so many tools. But just to sort of two main points is experience helps, and just look at the ground truth, look at the webcams, look at the Facebook groups, and just figure out when things are happening. Sort of just try and keep tabs as much as you can.
Yep. I think, at the beginning, a lot of us, okay, we keep KP. We know that was the first marketing term, right? That it's like, okay, that's going to be the strength. Where's it going to be? I don't know, but I know something's going to happen. It's going to be strong. So then I think the latest one that people are talking about is the BZ, right?
Yep.
Right.
Yep.
So Pat and Kat is asking you to explain why at times the need for the BZ to flip from positive for a brief time during sustained negative BZ.
That's a great question. So just so that everyone's on the same page, when I talk about BZ, BZ, what is that, right? Well, B as in Bravo, is the letter that scientists use to abbreviate magnetic field. I probably should know. I don't know why it's B and not M, but B stands for magnetic field. And there's an X, there's a Y, and there's a Z. So if you imagine, like, I'm doing this right-hand rule. If you're a physicist, you know what this is. It's the physics gang sign. You have an X and a Y and a Z in 3D space. So the Z is what we care about. That's the part that's pointing down. So when I was talking about Earth's magnetic field, there's, it's always pointing up. So if you have one that's pointing down, one that's pointing up, you bring them together, boom. You have this connection that is actually called magnetic reconnection that takes place. The energy transfers in. Great. That's how auroras kind of get charged up. It's kind of like the light switch for auroras. But when you get into the weeds, and I've read papers that have discussed this, you'll learn that, there's these things called auroral substorms where you have, over the course of, 30 minutes to an hour and 30 minutes, this BZ, if you have a lot of BZ, it starts charging up the aurora. Basically what happens is your magnetotail, remember we have Earth, we have the part that's facing this, let's say the sun's over here, and the part that's facing the sun is compressed, and you have the tail that, which extends out, sort of like a teardrop shape. Well, you have all these magnetic field lines that over the course of a big BZ sustained period, actually that energy doesn't necessarily go directly into the aurora. It can. Again, that's in a more advanced topic, but you start getting this this tail that becomes more and more stretched out. It's like taking a slingshot of aurora particles, and you're bringing it further and further and further back, and you're about ready to release it, but you just can't yet because there's nothing to tell you to release it. So sometimes to sort of kick things off, all that energy is being stored up, and it just grows and grows and grows. You need sort of it's almost like flapping a bed sheet or like shocking the system. You need a little bit of BZ north to kind of tell Earth, hey, let it go. So all these aurora particles then can slingshot back into the aurora ovals. And, of course, it's more complicated than that. But that's sort of the theatrical representation, is that you get all this, I like the charging
analogies.
up.
We need the analogies.
Yeah, analogies help. But yeah, you have all this charging up that happens with the BZ south. And to sort of get things going and trigger one of these substorms, which substorms are when the aurora goes nuts, it dances around, it lasts 15 to 30 minutes. It's a quick, explosive release of energy. You just need a little bit to sort of perturb the system, and that sometimes can be BZ north.
I love it. So we've been talking about obviously how beautiful and wonderful the auroras are and the solar storms behind them, but those can also be a little dangerous. Now you promised us that they're never going to hit Earth itself.
The aurora particles themselves won't hit us in the head necessarily.
But you better burst the bubble to us and share some of the dangers, or perhaps what we like to call the dark side of auroras.
Yeah. Well, yeah. So auroras themselves are beautiful, of course, but they signify these really intense currents going on in the upper atmosphere. So if you've taken a physics class, and even if you haven't, you've forgotten, maybe you remember, or you need to be reminded, that a changing magnetic field, a changing current in the atmosphere induces a changing current, a changing magnetic field in the ground. So it's called, it's the law of induction, basically. So when you have these auroras going nuts overhead and in the upper atmosphere, you also have these currents that are coursing in the ground. And usually that's fine. But if you have power lines, that are connected to the ground, as there are in many places in the world, especially where people, need power, these currents can travel up through the lines, right? And really, really conductive ground can, increase this charging rate. Really long runs of power lines. So actually in the US, particularly in the Iron Range of Minnesota and North Dakota, those are areas where there's a lot of, well, first of all, it's close to the aurora ovals. So there's usually more auroras up there. Minnesota, and it's also very rural. So you have very long runs of power lines. These voltages can build up over these long runs and cause transformers that are usually already weakened to fail. So essentially what happens, is, inside transformers, you have plates separated by paper, basically encased in oil. And, over time, water can seep in, over the course of decades, right? These, transformer, basically big buildings kind of break down. There's water that gets into the oil, and, under high stress, these plates heat up. So what happens when you have water soaked papers? You get steam. Well, really, hot steam and oil don't mix, and the transformers explode. So, these transformers go out all the time, right? People have to replace these. But if you have a big space weather event, you have, thousands of transformers all over the US that are suddenly experiencing loads that they have never experienced. You might get cascading failures, in which case, tons of aging transformers go down at once, and they can't be replaced in time. And you can have blackouts that, may last hours, days, or in the cases of, very extreme events, people have, predicted or theorized that you could have, even week or month-long blackouts. And, something even more powerful than the Carrington event may even cause, a sort of multi-trillion-dollar disaster. So auroras are really cool, but again, these currents in the ground can be very detrimental to equipment. Now, it's not necessarily this huge EMP. People get this idea that, a big solar storm hits and then, all the cars shut off and like your laptop dies. That's not going to happen. These voltages are actually very small. We're talking about like singular volts per kilometer. But when you have really long runs of power lines, now you're talking about a lot of volts because you have a lot of kilometers, right? So your laptop's not going to just get fried from an aurora overhead. The auroras also do not cause any sort of health effects. People will say, and there's really not that I've seen any like solid science basis for this, but people have experienced like feeling sick underneath the auroras, but physically there's no radiation that's actually coming down. So it could be psychological, it could be something else. I have heard that people with heavy metal who have had heavy metal poisoning actually do feel like a ringing or like tinnitus in their ears during really high geomagnetic activity, as well as experience more headaches. But yeah, the auroras themselves, and these currents happen all the time. But during really extreme events, they can be very detrimental. I'll just say one thing is that during the May event, so the Gannon storm, May 10th through 11th, 2024, these currents, and actually this just happened again, just like 2 weeks ago, and we had the big aurora, but not to the same degree. But Transpower, which is the power company, I think it's a national power company, I could be wrong, of New Zealand, had to shut down power to both islands during the storm.
Wow.
So they kind of reached these levels where they're taking action. So these power companies, obviously, they have a script, right? They don't just, they're not completely caught off guard. They have breakers that they'll flip if things get too wild. But yeah, they had to shut off power to a lot of people, and similar stories across other high latitude areas. So yeah, in 1989, for example, Hydro-Quebec, millions of people without power. Yeah, these things can happen. So,
wow. And plus all that space junk up there.
Yeah, I mean, I didn't talk about any of that. I was just talking about the aurora.
Exactly.
Whole
that's
host
that's a whole other thing.
Yeah.
All right. So, folks, I'm going to, and also, let's see. All right. Yes. I think we're caught up mostly on comments. Vincent, folks, let's take a deep breath here. We've taken a lot in. Vincent will be speaking at our upcoming Night Photo Summit, January 24th to the 26th. His class is appropriately titled Capturing Auroras, How to Photograph Nature's Most Spectacular Light Show. He's giving you a lot of information here, but you could tell, folks, there is a lot more that he's got under the hood. So in this session, Vincent will be providing details for photographing auroras with a phone, with a professional camera, and we'll really dive into the advanced concepts such as time-lapse photography and how to remove noise, flicker, as well as doing real-time video recording. Vincent, let's give the audience a tease of what they can expect and look at some of your images. And if you don't mind, let's share the story behind some of these shots. So I'm going to bring this to the stage. Let's see. We're going to go. There we go.
There it is.
All right. Where are we? One. This is it.
Yeah, this is the March 5th, 2022 aurora. So this was shot on, I believe, an A7R2. Yeah,
Okay.
A7R2. This was in 2015, I think, is when that one was released. But still takes great images. I think 1.6 second shutter speed, so that just gives you an idea of how bright the aurora was.
Yep.
I think I was at I think this was the 14-1.8 Sony GM. Love that lens. And yeah, this was my aurora. This was the one that really changed it for me. Just amazing. And the next day I looked at this photo and I was like, you know what? That thing is just like a cinnamon roll. So I named that the Aurora Cinnamon Roll. And this was taken in Fort Yukon, Alaska. So I was up there for a sounding rocket campaign. I was there for 3 weeks in the middle of nowhere above the Arctic Circle in Alaska. Take a bush plane to get there. I'm actually on this like Air Force base. So they have these long range radar sites. They're early warning missile sites for, they were built in the Cold War era. So that radar on the left is, whatever. I don't even know what it's doing, but it's to detect ICBMs coming from Russia. So It just so happens that they have a nice hotel there for researchers to stay when their sounding rocket launches. So that's why I was there. But yeah, this is a cool shot.
And OG is saying the same thing that I'm thinking. And the ground turned green, right? It's like everywhere you see.
Oh yeah, green, yeah. I forgot that people don't know that. It's the ground literally does turn green. Yeah, when it's really bright.
So is this whole thing a substorm? Is the cinnamon bun the substorm? And then you've got
the whole thing is just it's just one photo taken during the substorm. So I'll probably throw in a real-time video of this, but I had an A7 Mark IV going just to the right of this camera, looking the other way, but actually north is to the left, south is to the right. So you're seeing the aurora in this frame. I remember it was. And this is very typical in a substorm. The aurora starts, it builds, it kind of moves towards the south, and then it whips back to the north. So you're seeing this. It's called poleward expansion because north is towards the North Pole, moving poleward. So this is just one snapshot in this auroral substorm poleward expansion.
Beautiful, beautiful. And what do we got going
cinnamon
on
roll
here? Another
cinnamon roll.
Do they have cinnamon? They do have cinnamon rolls in Alaska, right?
Yeah, they do. This one, and they have them in Churchill too, because this is taken in Churchill, Manitoba. So September of 2022, I spent 3 weeks in Churchill. This was during a gap year, took a gap year between undergrad and grad school, and just kind of went around and just saw really cool places. So this is a pretty nice shot.
I love it. The boat, and everything. So this is also a fairly short exposure, probably something under
probably
2 seconds.
Yeah, under 5 seconds. Yeah, I think it's like 2 or 3 seconds. I think this one was with Sony. I think this is the Sony A7 Mark IV. I've sold my R2, so I was trying to, or I was like, the thing just kind of stopped working. But I got an R4 at some point, so I don't know which one this is, but I think it's a Mark IV.
I love the real clouds in the distance, right? And they're like low, right? And yet you've got the wispy on the left, and then really that cinnamon roll substorm just happening, and the green water, not the green land, but the green water. That's even better.
Everything turns green. Yeah,
everything just turns green. All right. Okay.
These are auroral beads, which are seen right before a substorm. So the beads, if they should be obvious, but they're these little, they kind of look like these little bright points of aurora. They start to form from a really quiet auroral arc. You'll see these beads form, and over the course of 30 seconds to 2 minutes, these beads will just erupt into this poleward expanding form, which then starts off the substorm. So the beads are part of the substorm initiation process. And this is in Iceland. And this was this was in 2023 January. So right when these substorms happen, you just have a bunch of particles coming in. So if you imagine all these particles of different energies, you have some that are lighting up this green layer, you have some that are lighting up this red layer, and all of them are funneling in, so you get all the colors just like kind of getting really intense at once.
And that's a ribbon too that we're seeing, right? Is that the okay? That's just coming right at us. That's awesome.
Yeah. So this was a pretty active night. I don't like KP, but it is helpful just to know like what it was at the time. I think this was a KP5. So for Iceland and Alaska, obviously, caveat, KP is not the greatest, but if you're into that, like a KP5 is like perfect for Alaska. That's even more is fine. But I mean, yeah, KP5, I mean, those auroras are usually great. I mean, usually it means that there's something going on in the solar wind, right? But my best auroras I've seen in Alaska, that one on March 5th, 2022, the first photo, that was a KP4. I think that Big Cinnamon Roll in Churchill is a KP4. This is a KP5. But some of the best auroras I've seen here in Fairbanks were at like KP1s, KP2s. I even had a KP0 that was just phenomenal. So,
What?
yeah, I mean, it's all about the quality of the substorm, because the substorm is really when rubber meets the road. It's like, this aurora just turned. You can get some really huge substorms at, fairly low KPs. They might not last a long time, but they're really intense. So
nice. All right.
Yeah.
Moving on from Iceland. Whoa.
This is back home in Fairbanks. So this is actually just a few miles from where I'm at now, off of Nordale Road, and I'm fine sharing these locations. This one's also very popular, so there's like pullouts on the side of the road. But this was February. I want to say this is February 14th, 2023.
Okay.
And yeah, so I called it the Valentine's Day storm. Had like 4 or 5 nights of just insane auroras. We had this, actually it was a coronal hole high-speed stream plus like a couple little CMEs that were just keeping the activity nice and juiced up for a while. And yeah, this thing was just so huge. This is actually a 12 mil, allow a 12 mil f2.8. So this thing is, it's very, very big. I mean, you're almost at the when you're at the zenith, or you're looking at the zenith, the aurora comes down in these rays, which we call corona. And actually, if I tilted my camera up a little bit more, you would have seen that aurora just coming straight down at you. So this thing was just massive. Yeah, I just really like this photo for the shapes. You can almost see like these fine details. I mean, the aurora in photos just never does it justice to the eye, because your eye can see it in real time. And the aurora has all these really, intricate shapes kind of swirling around, inside the larger, envelope, this larger form, this big blob. But, inside you have these like flickering patches, like 10 to 15 hertz flickering aurora that you can't even get on video half the time. It just looks crazy. So yeah, this is, another substorm. So yeah.
So when and this is, I would assume this is just one of the frames that then ended up being a time lapse as well.
Exactly. Yeah. I think this ended up being like a maybe 800 or 900 shot time lapse. So yeah,
I know you'll get more into this in the class, but I think this is sort of I just want to ask you just the question that obviously, this happens to all of us. We set up, do the time lapse. We know that we got to shoot that way for at least 30 minutes, an hour, whatever, however, we figure out our exposures. But then you're like, it was going over here, but now it's all the way over there, and I know you say you have multiple cameras, to cover, but do you just, sometimes are you like, pull it and, and move?
Yeah, I do that. Yeah. I have time lapse. I have time lapse ADHD, and I just start moving my camera everywhere. But one way that you can sort of alleviate that or give yourself the benefit of the doubt is just shoot at like 2 seconds, 2 seconds, 3 seconds. If the aurora is bright enough, that's actually plenty anyways. But, you can get like, your 240 shot time lapse in like, whatever, like 4 minutes or something.
Exactly right. So you can,
I mean, you could 4 minutes, 8 minutes, 10 minutes, you can get that, 10 seconds of footage, good to go, move it somewhere else. Cause I always try and get 10 seconds of footage, in real time, 240 shots, 24 frames per second. So
perfect. All right, good. Okay. All right. So this is the final image, and we're hitting the road with this one. This one is beautiful. A lot of reds, a lot of greens. Share.
Yeah, so this one is in, it's not really anywhere that you would, it's just off the side of the road. It's near Coldfoot, near actually Wiseman, Alaska. So Coldfoot, most people know what Coldfoot is or where that is. It's on the Dalton Highway. So you're looking actually down at just a tire track trail. The Alaska pipeline is to the right there, sort of threading through the image, and that connects Prudhoe Bay, the Arctic Ocean, with Valdez. And that's really, why this road exists and why Alaska exists, is gold and, these natural resources, oil. So this road called the Dalton Highway follows the Alaska pipeline from Fairbanks to Prudhoe Bay. You can drive it yourself. Definitely don't recommend if you are not, okay with driving on really sketchy roads. And you're going to want to grab a 4-wheel drive vehicle with, winter tires. But this was up near Wiseman. I think it was in February of 2023. And there was a, just beautiful substorm, at high latitude. It's a little bit, and this is like I don't even know how many hundreds of miles north of Fairbanks, but it's further within the Aurora Oval. So in Fairbanks, sometimes we have to wait a little bit for the auroras to sort of march down from the northern horizon overhead. But up there, I mean, those auroras come out overhead. So, and this is a really weird night. We had some activity. So, most of these photos were taken during some sort of geomagnetic storm or some sort of activity. We had this really high density solar wind. And usually what that means is these solar wind particles, there's so many of them, but they're actually not that energetic. They weren't traveling that fast. So it was just like, I don't know what it was, just like a plug of solar wind. But those create really vibrant colors. So, imagine all these really low energy particles. They're not making it all the way down to the lower border. They're just sort of, where all that red oxygen is being emitted. So you got all these really, vibrant red colors. So yeah, just really cool. And Sukapak Mountain is off to the left there. You have the black spruce trees. I think the air temperature in this photo was like -30 or -40 Fahrenheit. It was a little windy as well. You can tell it's windy because there's no snow on the trees either. So
okay.
Yeah.
Right.
So it was quite the night.
Pro tip there.
Quite the night.
Yeah.
Yeah. Quite the night. It was really awesome. And I think this was Sony A7 Mark IV 1418, I want to say, or something like that. I had all my cameras going, so I'm not sure which one it was, but yeah, nice. One of those.
Right on. Well, that brings us kind of to the sort of the next. We have a bunch of comments now, and OG is asking, how do you manage to manual focus with bare hands in the cold? So on a night like that, how are you? I mean, I know the mittens in Alaska, they're like super puffy. So are you setting infinity in the car, then going out, or what's your technique?
Well, actually, a little hack is a lot of these Sonys, these modern Sony G Master lenses are fly-by-wire focusing. So it's all, even though you're turning the focus ring on your lens, you think you're doing something. It's actually all electronics changing it for you. So what's really cool about that, and actually what's nice, is that once you've set your focus and you turn off your camera, that focus is set, and actually you can turn the focus ring and nothing happens because it's all fake, right? So I prefer that because I'm throwing the cameras in the camera bag and things get messed up. So when I turn on my camera, at least for me, right? Maybe I'm special, but it should just go right back to where you had it earlier. You don't actually have to refocus it. So you could focus it during the day, and focus it at infinity. Temperature does affect your focus a little bit though, so try and have your camera outside and focus. But that those focus elements move. Turn off your camera, and you could just set it up in the cold, once you roll out there, and it should be right where you left it, whatever 8 hours ago when you set it up in your house or outside. It's actually kind of nice. I didn't realize that. I was like, oh, I don't know why my focus is at infinity all the time. That's kind of cool. And then I looked into it, and I was like, oh, it's because of the lens. It's doing it for me. So.
And right, a lot of the mirrorless cameras are doing that. I know Nikon's doing that as well. Sony has that feature. So it is a cool feature that you can kind of set it to be like, hey, I want to go to infinity. That's sort of the default, but you got to set it. Or others might say, hey, I'm doing macro, so don't start there. I want to, I don't want to go there. But, and then you touched on a couple of locations, and this gets to a question. And folks, I know we're going overtime on this, but I see a lot of questions in here, and we're all having a good time. You got a few more minutes, Vincent?
Oh, yeah, I'm good.
All right. Okay. So you touched upon, one or two of the locations you shared. Thank you. And then Jet Trink is asking, what areas of Alaska would you recommend us to visit on an aurora hunt?
Anchorage and Fairbanks can both see auroras essentially nightly, although, Fairbanks will get that overhead band, Anchorage won't. So in Anchorage, on a really quiet night, you'll maybe see a little horizon glow. Sometimes it's not even visual to the eye, but you usually see something every single night. So Anchorage is better than Fairbanks in a lot of ways. There's more to do. It's closer to glaciers. It's closer to the big mountains. It's more accessible to reach, like, the southeastern parts of Alaska, Kenai, things like that. So, and it's also cheaper to fly into usually. So people like to go to Anchorage, but people like to go to Fairbanks if they want to see the aurora because it's further north. There's less light pollution because it's a smaller city. You can drive right out of town. I mean, you can see the auroras in town. I mean, I've pulled people out of the bar downtown and said, "Hey, look at that." So, you can see it pretty much right from in town, even in Anchorage too, even though Anchorage is bigger. Besides that, there's really not a whole lot of other places you can go in Alaska easily. I don't know what budget you have, or if you have people you can sort of set up in different spots. But I mean, if you wanted to, you could get out to a place like Fort Yukon. The problem is that there's really no hotels in any of these little villages, so it's kind of impossible to stay there. You could go up to a little town called Utqiagvik, or formerly known as Barrow. They have hotels there. There's also Prudhoe Bay. You can fly into Prudhoe Bay. Don't really recommend Prudhoe Bay. There's a lot of light pollution from the oil flares, and it's very cloudy up there. Even though you would think auroras would be just popping because it's so far north. It's just weather is not great. Nome is okay, but actually as you go further west, the aurora oval starts swinging away from you. So even though Nome is, I think, roughly at the same latitude as Fairbanks, it's actually worse for the auroras because the aurora oval is swinging away. And it's also pretty cloudy there. So yeah, Fairbanks is pretty much the best spot, and like the only main spot you really want to go. I mean, there's so many compositions, so many areas you can go from Fairbanks. I mean, the road network is great. Like there's roads in almost every single direction. It's not as good as you're going to get in like, the Midwest in the US, where everything is a nice, grid every 2 miles, or, these county roads are just going everywhere. You don't necessarily have that, but, it's better than like Churchill, Manitoba. It's better than Yellowknife. It's better than, Whitehorse, any of these places that, really it's just a town on a road, or like, for example, Yellowknife. Yeah. I mean, all you have is like the Dempster Highway, which you can barely drive anyways. So you have to fly in, and then there's like, 2 roads that go out for like 20 miles each. So Fairbanks is pretty nice.
So I imagine you land in Fairbanks, you go into the local bar, and like, straddle along the bar are all these seasoned drivers, and they're just waiting for that aurora chaser to come in and be like, "I can get you up to."
Yeah.
Is that true? Is that true? Is that how it happens?
Interesting. I mean, yeah. I mean that. You definitely see that sort of archetype in Fairbanks. These sort of truck driver, ice road trucker with like the 3-foot beards and whatever. I'm not going to go any further, but yeah. I mean, people are like that up here. I think a lot of people who are up here, there's a lot of trade workers. They don't necessarily know about the aurora. It's actually very funny. I've talked to truck drivers, and actually truck drivers see the aurora all the time because they're driving at night in the middle of nowhere. But like, I would say locals take it for granted. I don't think people in Fairbanks appreciate it enough. And it's just funny. Like, I've taken out people, and maybe not appreciate it enough, but I think it's just a point to make that even though you'd think everyone in Fairbanks is like, in tune to the aurora all the time because it's out every single night. A lot of the locals in Fairbanks have only seen it a couple times. That's crazy. And that's when the news tells them to go out, which is not always the best time to go out either. Especially at high latitudes. But yeah, it's just funny. It's like these people up in Fairbanks are just like, the average tourists in the lower 48 who go out when the news tells them to go out. It's just kind of funny. So,
well, I got to do a apartment swap with someone from Fairbanks and come to Brooklyn. I'll go there for a week, 2 weeks. We'll make that happen.
I mean, in the summer you're not going to see anything. So sure,
right, exactly. No, in the winter.
I'll take my place in the winter. Okay.
All right. So, following up on that. Question: favorite places in Alaska? If you could live in one place to watch the auroras for a winter outside of Fairbanks, I would even say outside of Alaska, unless you got some place.
Just anywhere in the world.
Anywhere in the world. Where would that be?
I'd probably say Yellowknife, Northwest Territories. Even though I was just talking about the road network in Yellowknife, it's like perfectly positioned underneath the aurora oval. The weather from what I know, is fairly similar to Fairbanks. So actually, Fairbanks is pretty dry compared to a lot of these places around the world, like Iceland or like Lofoten, Norway, or like Tromsø. Like these places that are near the coast are fairly cloudy.
Yep.
And it varies from season to season too. Like I know Northern Europe, like Norway, Sweden, Finland have been having a fantastic season, like super, super clear. But usually it's, cloudier in these areas. Yellowknife is fairly clear, especially during the fall and the spring. Same with Fairbanks, February to April really clears up. It's been pretty clear this winter actually here in Fairbanks too. But Yellowknife is further east, even though it's further south. The Aurora Oval dips down the furthest over, actually like the Hudson Bay, like over Churchill. So you don't need to go as far north to see the aurora at those longitudes. So Yellowknife is really, perfectly positioned. Also, there's places, around the world. I'm not going to get the exact cities right, but I think, like Abisko, Sweden is in this nice rain shadow, and they get tons of aurora, like, I don't know, 200 nights of aurora, a year or something crazy.
Nice.
So I wouldn't mind living somewhere like that, or like really high altitude where you don't have any clouds forming, or, like any of these places. Clouds are sort of the biggest factor for me. I mean, I want to live somewhere that's dry, underneath the Aurora Oval, because you're going to get the same, you're always going to see it. So you just want to see it as many times as you can, basically.
Nice. So we have I think 1 or 2 questions left in the chat, and then we'll let you go. Justin from Maine is asking, what do you think one of the next groundbreaking aurora discoveries will be?
Ooh, there's so many. I think that's the thing, is that I mean, well, one thing that I'm passionate about is like these really rare auroral phenomena. So have you heard of Steve?
Yes, of course. Yeah, Steve.
Okay, so you have. So there's this aurora, I use quotes because
yes,
we don't think it's actually aurora, but stands for Strong Thermal Emission Velocity Enhancement. Okay, it was discovered by citizen scientists, by aurora chasers, primarily in the Alberta aurora chasing community. They actually didn't discover it; it's always been around. But they noticed it in their photos and then raised it to scientists, and then they collaborated and made the conclusion that, hey, this ribbon of sort of white emission in the sky is not really an aurora; it's something completely different. So, I think if we can understand what Steve is and how it's formed, why it forms, where it does, under what conditions, and also model a lot of this stuff. A lot of what science is observations. It's theory, observations, and also modeling, right? We've gotten so good with AI and machine learning computers that it'd be really cool to get a model of like aurora, for example, like actually putting in all the equations and just hitting go and seeing these cinnamon rolls, for example, pop up in your movie, right? All from the theory. So I think that'd be really cool. I think the thing is that even though aurora science has been around for as long as humans have existed, and there's sort of the Western science, but there's also all the indigenous knowledge too, and that's existed for hundreds of thousands of years. Even though we've known about the aurora for so long, we've witnessed it, we have stories about it, we still don't really know, all these little things. Like we don't know what causes an auroral substorm and how that works. We just don't have that nailed down. We don't have a lot of these things nailed down. So yeah, lots of things.
Well, we're counting on you, the aurora guy. You got to get your green cape.
I'm gonna try my best. I'm gonna try my best.
All right. Well, the last question: best month to see the aurora in Fairbanks?
March.
Yeah,
right. March. It's the clearest, and auroral activity. It's kind of unknown. Actually, this is another unknown. Why the auroral activity peaks around the equinoxes? I mean, there are theories, and there are certain like effects that happen, but around the equinoxes, not necessarily at the equinox itself, but the months around. So let's say August, October, February to April. There's more substorms, basically. So more of these big bursts of activity, especially when space weather is quiet. So February to April, really good time to come to Fairbanks. Relatively warm, not -40, maybe -20 Fahrenheit.
That's nice. That's nice. That's
yeah,
helpful.
It's balmy.
7 layers, also, not 10.
Yeah, and also more rural activities. So March is sort of the best month. Yeah.
Right on. And that's my birthday month for anyone interested. There
you go.
All right. Well, Vincent, thank you so much. This has been awesome. Really, really appreciate You dropping the knowledge here with us tonight, the dropping the inspiration. We're also excited to chase those green fairies. Hopefully at higher latitudes, but hopefully get some more opportunities to see them at those mid latitudes as well. Again, I got my fingers crossed this year. I'm forever optimistic that it'll be another powerful year as we climb maybe a little bit closer to that maximum.
Hopefully, I'm very optimistic. So I think we're going to get another fantastic year.
Awesome. And folks, thank you. That you've been a wonderful group. This has been great. This rewatch, if in case you came in just a little bit, this rewatch will be wrapped up and available on our Instagram page, both the Night Photo Summit and National Parks at Night, in about 5 to 10 minutes. And you can rewatch it at your leisure. You can pick it up, watch some of it, come back and watch it again. But if you are also passionate about night photography, consider also joining us and other like-minded people at our annual Night Photo Summit virtual conference this January 24th to the 26th. Vincent will be there, as well as 40 other presenters, 50 hours of inspiration, instruction, and fun. We've got camaraderie, community, and a stellar glow-in-the-dark conference t-shirt. Vincent, you're going to be getting yours mailed to you soon.
Excited.
And if you can't make it that weekend, or you're just going to miss one of the days, 2 of the days, you get a free online access after you with your registration for up to for the year following. So you could just kind of take it at your pace. We've got 3 or 4 tracks going at once, so you're not going to be able to see everything that weekend, but there's a ton to watch at your leisure. So level up your skills with over 3 full days of night photography education and inspiration at 2025.nightphotosummit.com. Again, thank you, Vincent, so much. For those of you who enjoyed this talk, we're doing a few more this week. We got 3 more this week. Next up is Sarah Matthews, who was with us at Nightscaper. She's a astrophotographer and space enthusiast. She'll be joining us Wednesday at 8 p.m. So come in, join us for another episode of Night Talk. But again, thank you all. Thank you, Vincent. We wish you green skies.
Yes. Thank you.
All right. So that's stopped here. And now we're waiting at spool out.